What if I told you that right now, as you're watching this video, every moment of your future has already happened? What if your next birthday, your next meal, even the last day of your life exists somewhere in the universe at this very moment? It sounds like science fiction, but according to some of the brightest minds in physics, this might actually be our reality. Welcome back to the channel, everyone. I'm your host, and today we're diving deep into one of the most mind-bending questions in all of science. Is time really an illusion? And if it is, what does that mean for free will, causality, and our entire understanding of existence? This isn't just philosophical speculation. We're talking about cutting-edge physics, from Einstein's relativity to quantum mechanics, from the nature of consciousness to the very fabric of space-time itself. But before we begin, make sure to hit that subscribe button and ring the notification bell. The illusion of now. Let's start with something that seems absolutely fundamental to human experience: the present moment. Right now, as you're listening to these words, you feel like you're experiencing now. But here's the first mind-bending revelation. According to physics, there is no universal now. Think about it this way. You're watching this video and you feel like we're sharing this moment together. But the light from your screen took time to reach your eyes. The sound took time to reach your ears. Even the electrical signals in your brain take time to process what you're experiencing. So when exactly is now? This gets even more complicated when we zoom out to cosmic scales. The light from the sun takes about 8 minutes to reach Earth. So when you look at the sun, you're actually seeing it as it was 8 minutes ago. The nearest star, Proxima Centauri, appears as it was over 4 years ago. And when we look at distant galaxies, we're seeing them as they were billions of years ago. But here's where it gets really strange. According to Einstein's theory of relativity, there's no absolute reference frame for time. What you consider to be happening right now depends entirely on your motion and your position in a gravitational field. Two observers moving at different speeds will disagree about which events are simultaneous. Imagine you're on a train moving at high speed and your friend is standing on the platform. When the train passes your friend, you both look at your watches and synchronize them to show exactly noon. Now, as you continue traveling, you'll look out the window at a clock tower in a distant city and see that it reads 12:05. Your friend, still on the platform, looks at the same clock tower and sees 12:07. Who's right? According to relativity, you both are. Time itself is relative. There's no universal clock ticking away in the background of the universe. The concept of simultaneity, of things happening at the same time, only makes sense within a specific reference frame. This leads us to our first major revelation. If there's no universal now, then our everyday experience of time, flowing from past to present to future, might be nothing more than an illusion created by our limited perspective. The block universe theory. This brings us to one of the most profound concepts in modern physics: the block universe theory, also known as eternalism. Picture the universe not as a constantly changing, flowing river of time, but as a solid, unchanging block. In this block universe, every moment that has ever existed or will ever exist is equally real. Your birth, your childhood, this moment right now, your future career, and even your death are all embedded in this four-dimensional block of space-time like flies trapped in amber. The great physicist Hermann Minkowski, who was Einstein's teacher, first proposed this idea when he said, "Henceforth, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality." Think of it like a movie reel. When you watch a movie, you experience it as unfolding through time, with scenes happening one after another. But the entire movie actually exists on the reel simultaneously. Every frame, from the opening credits to the final scene, is there at the same time. You only perceive it as sequential because of the way your consciousness moves through it. In the block universe theory, space-time is like that movie reel, and consciousness is like the projector, creating the illusion of temporal flow by experiencing one frame of reality after another. But wait, you might be thinking, surely this can't be right. If the future already exists, What about free will? What about the choices we make? This is where things get really fascinating, and we'll explore this paradox in depth as we continue. For now, let's examine the evidence for the block universe. Einstein himself was a strong proponent of this view. When his lifelong friend Michel Besso died, Einstein wrote a letter of condolence to Besso's family, saying, "For us believing physicists, the distinction between past, present, and future is only a stubbornly persistent illusion." This wasn't just philosophical musing. Einstein's theory of special relativity mathematically demonstrates that simultaneity is relative. Events that appear simultaneous to one observer may not be simultaneous to another observer in motion. This suggests that all events in spacetime have equal ontological status. They're all equally real. Relativity and the nature of time. Let's dive deeper into how Einstein's theories revolutionized our understanding of time. Before Einstein, time was thought to be absolute and universal. Newton imagined time as flowing uniformly throughout the universe, like a cosmic metronome keeping perfect rhythm. Einstein shattered this conception with two groundbreaking theories: special relativity and general relativity. Special relativity, published in 1905, revealed that time is intimately connected with space and motion. The faster you move through space, the slower you move through time. This isn't just theoretical. It's been experimentally verified countless times. GPS satellites, for instance, have to account for time dilation effects, or they would be off by miles. But here's the mind-bending part. From your perspective, your own time always feels normal. If you were traveling at 99% the speed of light, your watch would tick normally. You'd age normally. Everything would seem completely ordinary to you. It's only when compared to someone in a different reference frame that the time dilation becomes apparent. General relativity, published in 1915, added another layer of complexity by showing that gravity affects time as well. The stronger the gravitational field, the slower time moves. This means that time actually runs slightly faster on the top floor of a skyscraper than it does at ground level, because gravity is marginally weaker up there. These effects create what physicists call the relativity of simultaneity. Events that are simultaneous for one observer may not be simultaneous for another. This has profound implications for our understanding of reality. Consider this thought experiment. Imagine Alice is on Earth, and Bob is traveling to a distant star at high speed. When Alice looks at her clock and sees that it's exactly midnight, what time is it for Bob? The answer depends on Bob's velocity relative to Alice. But here's the crucial point. If Bob is moving toward the star, then according to relativity, events that Alice considers to be in the future are actually happening now in Bob's reference frame. Conversely, if Bob is moving away from the star, then events that Alice considers to be in the past are happening now for Bob. This suggests that the future, in some sense, already exists. It's not that it will exist, it does exist, right now in some reference frame somewhere in the universe. Quantum mechanics and time. But wait, there's more complexity to add to our understanding of time. While relativity suggests that time is an illusion and that all moments exist simultaneously, quantum mechanics introduces an entirely different perspective on time and reality. In the quantum world, particles don't have definite properties until they're observed. Instead, they exist in what's called a superposition of all possible states. The famous Schrödinger's cat thought experiment illustrates this. A cat in a box is simultaneously alive and dead until someone opens the box to observe it. This raises fascinating questions about time and causality. If quantum events are truly random and unpredictable, how can the future already exist? How can there be a predetermined block universe if quantum mechanics shows us that the universe is fundamentally probabilistic? Some physicists argue that quantum mechanics actually supports the idea of time as an illusion, but in a different way. They suggest that what we perceive as the flow of time is actually the result of quantum dicoherence, the process by which quantum superpositions collapse into definite states. In this view, the universe is constantly choosing which reality to manifest from an infinite array of possibilities. The arrow of time emerges from this process of decoherence, giving us the illusion that time flows from past to future. But other physicists disagree. They argue that quantum mechanics introduces genuine randomness into the universe, making the future truly open and undetermined. In this interpretation, the block universe theory can't be completely correct, because there are aspects of the future that simply don't exist yet. This leads us to one of the most hotly debated topics in physics: the measurement problem. When does a quantum superposition collapse into a definite state? Is it when a conscious observer makes a measurement? Is consciousness somehow special in determining the flow of time? Some theories, like the many worlds interpretation of quantum mechanics, suggest that all possible outcomes of quantum events actually occur simultaneously in parallel universes. In this view, time doesn't flow at all. Instead, consciousness branches along with the splitting universes, creating the illusion of temporal progression. The arrow of time, if time is truly an illusion, then why do we experience it as flowing in one direction? Why do we remember the past but not the future? Why do we see causes leading to effects, but not effects leading to causes? This is known as the arrow of time problem. There are actually several different arrows of time that physicists have identified. The thermodynamic arrow points in the direction of increasing entropy or disorder. The cosmological arrow points in the direction of the universe's expansion. The electromagnetic arrow points in the direction that electromagnetic waves propagate. And the psychological arrow points in the direction of our subjective experience of time. The most fundamental of these is probably the thermodynamic arrow. The second law of thermodynamics states that entropy, or disorder, always increases in a closed system. This gives us a clear direction for time. The past is the direction of lower entropy, and the future is the direction of higher entropy. But here's the puzzle. The fundamental laws of physics are mostly time-symmetric. If you filmed a movie of particles colliding and then played it backward, you wouldn't be able to tell which direction was forward in time just by looking at the particle interactions. The laws of physics work equally well in both directions. So why does the universe have a preferred direction in time? The answer seems to lie in the initial conditions of the universe. The Big Bang created a universe in an extremely low entropy state. Ever since then, entropy has been increasing, giving us the arrow of time we observe. But this raises another question. If the block universe theory is correct, and all moments in time exist simultaneously, then why does the universe have this particular structure, with low entropy in one direction and high entropy in the other? It's almost as if the universe was designed to create the illusion of temporal flow. Some physicists have suggested that our perception of time's arrow is simply a consequence of how our brains work. We remember the past because memories are physical traces left by past events, increasing the entropy of our brains. We can't remember the future because creating memories of future events would require decreasing entropy, which violates the second law of thermodynamics. Consciousness and the perception of time. This brings us to one of the most profound questions in all of science. What role does consciousness play in our perception of time? If time is indeed an illusion, then consciousness must be the magician creating the trick. Think about your own experience of time. When you're bored, time seems to crawl by. When you're having fun, time flies. When you're in danger, time seems to slow down. When you're asleep, hours can pass in what feels like an instant. Clearly, consciousness plays a major role in how we experience time. But it goes deeper than that. Some neuroscientists argue that consciousness itself creates the illusion of temporal flow. The brain takes snapshots of reality and strings them together into a narrative. Much like how individual frames of a movie create the illusion of motion when played in sequence, your brain is constantly predicting the future based on past experience. It creates models of reality that help you navigate the world. These models include a strong sense that time flows from past to future, because that's the most useful way to organize information for survival. But what if consciousness is doing something even more fundamental? What if the act of conscious observation is what creates the experience of now? Some interpretations of quantum mechanics suggest that consciousness plays a special role in collapsing quantum superpositions, effectively choosing which reality we experience. This leads to some mind-bending possibilities. Consciousness creates the experience of now. And if different conscious beings can have different reference frames due to relativity, then different conscious beings might literally inhabit different nows. Your now might be different from my now, even if we're sitting in the same room. Some philosophers and physicists have suggested that consciousness might be the only thing that truly moves through the block universe. While all events in spacetime exist simultaneously, consciousness provides a spotlight that illuminates different moments, creating the subjective experience of temporal flow. Free will in a block universe. If the future already exists, what happens to free will? This is perhaps the most troubling implication of the block universe theory for many people. How can we make meaningful choices if our futures are already written in the fabric of spacetime? There are several ways physicists and philosophers have approached this problem. One approach is compatibilism, the idea that free will is compatible with determinism. In this view, you have free will as long as your actions flow from your own desires and reasoning, even if those desires and that reasoning are themselves determined by prior causes. From this perspective, the fact that your future actions already exist in the block universe doesn't negate your free will any more than the fact that your past actions are fixed negates your past free will. Your future choices are real choices, made by your future self based on your future mental states. The fact that these choices already exist in spacetime doesn't make them any less yours. Another approach is to argue that quantum mechanics introduces genuine randomness into the universe, preventing the future from being completely determined. If quantum events are truly random, then the future might be partially open, even in a block universe. But randomness alone doesn't solve the free will problem. Random events aren't freely chosen events. If your actions are determined by random quantum fluctuations, that doesn't seem to give you any more free will than if they were determined by classical physics. Some philosophers argue for a more radical solution. Maybe free will is itself an illusion, just like the flow of time. Perhaps what we experience as making choices is just the brain's way of rationalizing actions that were always going to happen. But here's an interesting twist. Even if free will is an illusion, the illusion itself might be necessary for the proper functioning of consciousness and society. Believing in free will might be essential for moral responsibility, motivation, and social cooperation, regardless of whether it's metaphysically real. The many worlds interpretation. One of the most radical solutions to the time paradox comes from the many worlds interpretation of quantum mechanics. According to this theory, every quantum measurement causes the universe to split into multiple parallel realities, one for each possible outcome. In the many worlds view, time doesn't flow at all. Instead, there's a vast, ever-branching tree of parallel universes, each representing a different possible history. What we perceive as the flow of time is actually our consciousness following one particular branch of this tree. This solves several problems at once. It preserves the block universe while explaining quantum randomness. It maintains determinism while allowing for apparently random events. And it provides a kind of free will. Because even though all possible choices are made somewhere in the multiverse, you still get to experience making your particular choices. But the many worlds interpretation comes with its own mind-bending implications. If it's correct, then there are countless versions of you right now, living slightly different lives in parallel universes. There's a version of you who chose differently at every decision point, a version who experienced different random events, a version living a completely different life. In some branches of the multiverse, you never existed at all. In others, you're the most famous person in the world. In still others, history unfolded completely differently, and human civilization never developed. This raises profound questions about identity and meaning. If there are infinite versions of you, which one is the real you? Does it matter what choices you make if every possible choice is made by some version of you? Some physicists and philosophers find the many worlds interpretation liberating. It suggests that every possible life is lived, every possible choice is made. Every possible outcome is realized somewhere in the vast multiverse. Others find it deeply disturbing, reducing our choices and experiences to just one thread in an infinite tapestry of possibilities. Time travel and causality. No discussion of time would be complete without addressing time travel. If time is an illusion and all moments exist simultaneously, does that make time travel possible? The answer is surprisingly complex. Einstein's general relativity actually allows for several theoretical forms of time travel. Closed time-like curves, wormholes, and extreme gravitational effects can all potentially allow for travel to the past. But these solutions come with serious problems, most notably causality paradoxes. The grandfather paradox is the most famous of these. If you travel back in time and prevent your grandparents from meeting, how could you have been born to travel back in time in the first place? This creates a logical contradiction that seems to rule out time travel to the past. But some physicists have proposed ingenious solutions to these paradoxes. The Navikov self-consistency principle suggests that the laws of physics would somehow conspire to prevent any paradox-creating actions. If you tried to kill your grandfather, something would always intervene to stop you. The many worlds interpretation offers another solution. When you travel back in time, you don't change your own past, but instead create a new branch of reality. You might prevent your grandparents from meeting in this new timeline. But that just means this version of them won't have grandchildren. You yourself came from a different branch where they did meet. But here's the thing. If the block universe theory is correct, then, in a sense, we're all time travelers. We're constantly moving through the four-dimensional space-time manifold, experiencing different slices of eternity. The only difference between normal time travel and the exotic kind is the direction and speed of movement through the block. Some physicists have even suggested that consciousness itself is a kind of time travel device, allowing us to experience different moments of the eternal block universe. In this view, memory is a form of backward time travel, and anticipation is a form of forward time travel. The emergent time hypothesis. Not all physicists accept the block universe theory. Some argue that time is not fundamental but emergent, arising from more basic physical processes. This is similar to how temperature emerges from the motion of atoms, or how wetness emerges from the behavior of water molecules. In emergent time theories, the fundamental level of reality might be timeless, but time emerges at larger scales through various mechanisms. Quantum entanglement, thermodynamic processes, or the expansion of the universe might all contribute to the emergence of temporal experience. One promising approach is the thermal time hypothesis, which suggests that time emerges from thermodynamic processes. In this view, the flow of time is intimately connected to the increase of entropy. Conscious beings like us experience time because we're thermodynamic systems that create entropy. Another approach is the causal set theory, which proposes that space-time is not continuous but made up of discrete, indivisible units. In this theory, time emerges from the causal relationships between these fundamental events. The flow of time is the result of causality propagating through the network of events. Loop quantum gravity offers yet another perspective, suggesting that time emerges from the quantum geometry of space itself. At the smallest scales, space and time might be granular rather than smooth, and the familiar space-time of relativity emerges only at larger scales. These emergent time theories offer a potential middle ground between the block universe and our intuitive experience of temporal flow. They suggest that time is real and fundamental to our experience, even if it's not fundamental to the deepest level of physical reality. The measurement of time. Let's take a step back and consider how we actually measure time. Our most precise atomic clocks work by counting the oscillations of atoms. But even these are based on the assumption that the laws of physics remain constant. What if the rate at which atoms oscillate is itself changing over time? Some theories in cosmology suggest that fundamental constants, including those that determine atomic oscillation rates, might vary over cosmic timescales. If this is true, then our measurements of time might be relative not just to our motion and gravitational field, but also to the era of the universe we're living in. This raises deep questions about the nature of time measurement. When we say that a day is 24 hours long, we're really saying that it takes a certain number of atomic oscillations for the Earth to rotate once relative to the Sun. But all of these processes, the atomic oscillations, the Earth's rotation, and the Sun's motion, are ultimately governed by the same underlying physical laws. In a sense, we're using time to measure time, which creates a kind of circular definition. This circularity has led some physicists to suggest that time might not be a fundamental quantity at all, but rather an emergent property of the relationships between different physical processes. The Global Positioning System provides a perfect example of how complex time measurement can be. GPS satellites have to account for both special relativistic effects and general relativistic effects. Without these corrections, GPS would be off by miles. But even with these corrections, GPS assumes that there's some absolute reference frame for time, usually defined by atomic clocks on Earth. This works well for practical purposes, but it highlights the fact that time measurement is always relative to some chosen standard. Time in different cultures and philosophies, our scientific understanding of time has been profoundly shaped by Western philosophical traditions. But other cultures have developed very different concepts of temporality. These alternative views might offer insights into the nature of time that complement our scientific understanding. Many ancient cultures had cyclical rather than linear concepts of time. The Hindu concept of cosmic cycles, for instance, describes time as repeating patterns of creation and destruction spanning billions of years. In this view, time is not a straight line from past to future, but a wheel that turns eternally. Buddhist philosophy offers another perspective, emphasizing the illusory nature of time and the importance of living in the present moment. The Buddhist concept of impermanence suggests that all things are constantly changing, and that our attachment to the past and future causes suffering. Indigenous cultures around the world often have very different relationships with time than modern Western society. Some cultures don't distinguish sharply between past, present, and future. Instead, viewing time as a more fluid, interconnected phenomenon where ancestral wisdom and future possibilities coexist with present experience. These philosophical perspectives resonate surprisingly well with some interpretations of modern physics. The Buddhists' emphasis on the illusory nature of time aligns with the block universe theory. The Hindu concept of cyclical time echoes some models of cosmology. The indigenous understanding of interconnected temporality reflects the insights of relativity. Perhaps most intriguingly, many mystical traditions speak of experiences that transcend ordinary time. Mystics report states of consciousness where time seems to stop, where past and future collapse into an eternal present, where the usual flow of temporal experience dissolves entirely. These reports are often dismissed as subjective hallucinations, but they might actually provide clues about the nature of consciousness and its relationship to time. If time is indeed an illusion created by consciousness, then altered states of consciousness might reveal different aspects of temporal reality. The psychology of time perception. From a psychological perspective, our experience of time is remarkably malleable. Children experience time differently than adults. People with certain mental conditions have altered time perception. Even healthy individuals can have dramatically different experiences of temporal flow under different circumstances. Neuroscientists have identified several brain regions involved in time perception, including the suprachiasmatic nucleus, which regulates circadian rhythms, and various areas in the prefrontal cortex and basal ganglia that are involved in temporal processing. But there's no single time center in the brain, Instead, time perception emerges from the coordinated activity of multiple neural networks. This distributed nature of time perception in the brain supports the idea that temporal experience is constructed rather than directly perceived. The brain takes inputs from various sensory systems and internal processes and integrates them into a coherent sense of temporal flow. Interestingly, different types of time perception seem to involve different neural mechanisms. Perceiving brief intervals involves different brain areas than perceiving longer intervals. This suggests that there might not be a single, unified time sense, but rather multiple overlapping systems for temporal processing. The psychology of time perception also reveals how deeply social and cultural factors influence our experience of time. Different cultures have different attitudes toward punctuality, different concepts of appropriate timing for various activities, and different ways of organizing temporal experience. These cultural differences in time perception might reflect deeper philosophical differences about the nature of reality and human experience. They remind us that our scientific understanding of time, impressive as it is, represents just one way of thinking about temporality among many possible approaches. The future of time research as we push the boundaries of our understanding. New technologies and theories are opening up fresh perspectives on the nature of time. Quantum computers might help us explore the relationship between quantum mechanics and temporal experience. Advanced gravitational wave detectors are allowing us to probe extreme space-time conditions where relativistic effects are most pronounced. Emerging theories in physics are also offering new insights. String theory, for instance, suggests that time might have multiple dimensions, just as space does. Loop quantum gravity proposes that time itself might be quantized, made up of discrete, indivisible units. Perhaps most intriguingly, some researchers are exploring the possibility that consciousness itself might play a fundamental role in the structure of spacetime. If consciousness is necessary for the collapse of quantum wave functions, then conscious beings might literally participate in the creation of reality, including the flow of time. Artificial intelligence research is also contributing to our understanding of time perception. As we develop more sophisticated AI systems, we're learning about how temporal processing might work in non-biological systems. Some AI researchers are even exploring whether artificial consciousness might experience time differently than biological consciousness. The convergence of neuroscience, physics, computer science, and philosophy is creating new interdisciplinary approaches to understanding time. We're beginning to see how the subjective experience of temporal flow might relate to the objective structure of spacetime described by physics. These developments suggest that our understanding of time is still evolving rapidly. The next few decades might bring revolutionary insights that transform our conception of temporality as dramatically as Einstein's theories transformed our understanding a century ago. Practical implications. You might be wondering, even if time is an illusion, does it really matter for everyday life? The answer is both yes and no. On one level, these insights don't change the practical necessities of living in the world. You still need to show up for appointments on time, plan for the future, and learn from the past. But on a deeper level, understanding the nature of time can profoundly change how we relate to our existence. If the block universe theory is correct, then every moment of your life has equal reality. Your childhood exists just as much as this present moment. Your future exists just as much as your past. This perspective can be both comforting and challenging. It's comforting because it suggests that nothing is ever truly lost. Every happy moment, every achievement, every experience of love and connection exists eternally in the structure of spacetime. Death becomes not an ending, but simply a boundary of your particular thread through the block universe. But it's challenging because it calls into question our ordinary assumptions about agency, meaning, and purpose. If your future already exists, what's the point of trying to change it? If every moment has equal reality, why should you prefer some moments over others? Different people respond to these insights in different ways. Some find them liberating, feeling freed from anxiety about the future and regret about the past. Others find them disturbing, feeling that they undermine the meaning and significance of human choice and action. Perhaps the most balanced approach is to hold these insights lightly. The scientific evidence for the illusory nature of time is compelling, but it doesn't negate the importance of our subjective experience. Even if time is an illusion, it's an illusion that we're embedded in so deeply that we can't escape it. Questions as we near the end of our journey through the time paradox. Let's return to the ultimate questions that started our exploration. Is time really an illusion? Does the future already exist? What does this mean for consciousness, free will, and the meaning of existence? The honest answer is that we don't know for certain. The evidence from physics strongly suggests that our ordinary experience of time as a flowing river is misleading. The block universe theory, supported by relativity and consistent with much of quantum mechanics, indicates that all moments in time have equal reality. But there are still deep mysteries. We don't fully understand how consciousness relates to time or why we experience temporal flow if it's illusory. We don't know whether quantum mechanics ultimately supports or undermines the block universe theory. We don't know how to reconcile the apparent determinism of the block universe with the apparent randomness of quantum events. These uncertainties aren't failures of science, but rather signs of how much more there is to discover. Each answer we find reveals new questions. Each solution uncovers new mysteries. This is what makes science so exciting and so humbling. What we can say with confidence is that time is far stranger and more subtle than our everyday experience suggests. The universe is not the simple, predictable clockwork that Newton imagined, nor is it the chaotic, random system that some interpretations of quantum mechanics suggest. It's something far more mysterious and wonderful. Perhaps the most important insight from our exploration is that reality is far richer and more complex than any single perspective can capture. Science gives us one powerful way of understanding time, but philosophy, psychology, to subjective experience offer other valuable insights. The time paradox teaches us humility about the limits of human understanding, while simultaneously revealing the incredible power of human reasoning to uncover deep truths about the nature of reality. We are conscious beings embedded in a universe that we're only beginning to understand, and that's both humbling and exhilarating. Living with the paradox, so where does this leave us? How should we live with the knowledge that time might be an illusion and that the future might already exist? I think the answer is to embrace the paradox rather than trying to resolve it. We are beings who experience temporal flow, even if that flow is ultimately illusory. We make choices, even if those choices are already embedded in the structure of space-time. We create meaning, even if the universe is fundamentally deterministic. The fact that time might be an illusion doesn't make our experiences less valuable or meaningful. Love, creativity, discovery, and growth are no less precious for being embedded in an eternal block universe. If anything, the idea that these experiences exist eternally might make them more precious, not less. Perhaps the most profound insight from our journey is that consciousness itself might be the most mysterious aspect of reality. In a universe where time is an illusion, consciousness seems to be the one thing that creates the experience of temporal flow. We are not just passive observers of reality, but active participants in creating the experience of time itself. This places enormous responsibility on us as conscious beings. If we are the ones who create the experience of now, then how we choose to direct our attention, how we choose to experience each moment, becomes cosmically significant. Every moment of awareness is a creative act. It's a choice about which aspect of the eternal block universe to illuminate with consciousness. The time paradox ultimately returns us to the most fundamental questions about existence. Who are we? Why are we here? What does it mean to be conscious in an apparently material universe? These questions don't have easy answers, but they're the questions that make us human. As we continue to explore these mysteries, both through scientific investigation and through personal reflection, we participate in one of the most remarkable phenomena in the known universe: the emergence of consciousness capable of contemplating its own existence and the nature of reality itself. Whether time is an illusion or not, whether the future already exists or not, we remain conscious beings capable of wonder, love, creativity, and discovery. And that, perhaps, is the most miraculous thing of all. Thank you for joining me on this incredible journey through the time paradox. I hope it's given you new ways of thinking about time, consciousness, and reality. If you enjoyed this exploration, please give the video a thumbs up, subscribe to the channel, and let me know in the comments what aspects of the time paradox you find most fascinating or troubling. Remember, the universe is far stranger and more wonderful than we can imagine, and we're only just beginning to understand it. Keep questioning, keep wondering, and keep exploring. The next breakthrough in our understanding of time might come from someone just like you. Until next time, whenever that might be in the grand block universe of space-time. Keep thinking, keep learning, and keep marveling at the incredible mystery of existence itself.